Alright, so we're going to talk about the area of regular polygons, and your learning target is I can use the formula for the area of a regular polygon. Now, before we get going, I just want to give you a little warning. This is kind of a new little bit of stuff here, and so it takes a little bit of practice, and it takes a lot of effort on your part. You're really going to have to make sure that you focus in on what I'm saying, and you may have to watch the video once, twice, maybe even a third time. It's a little bit confusing. Just make sure you take it slow, pause the video if you need to, and keep watching it. It can get a little bit confusing at times, but it's fairly simple. It just takes a few little steps to kind of try to focus in on what exactly is happening. So let's do some definitions here. The first thing we're going to define is an apothem. Okay, the apothem is the distance from the center. Okay, that first blank is center of a polygon to the midpoint of a side. Okay, so if you look down at example 1 real quick, I'm going to move this down. If you look at example 1, the apothem is the distance from the center all the way to the midpoint of one of the sides here. So this distance right here that's called the apothem. Okay. Now the second part we're going to define here now is the central angle. Okay, so that center angle, the very middle, where we take the apothem from, right, of a regular polygon has its vertex at the center of the polygon and connects with two consecutive vertexes, creating many triangles. Okay, the same number of triangles as the number of sides. So that's saying, again, if I move this down, that's saying all of these sides. We create many triangles, right? So I have a triangle right here. Create a triangle right through here, through there, that type of a thing, right? And the amount of triangles we're going to have is the same amount of sides that we have. All right. Now getting back up here, to find the measure of one of these angles, we simply use the formula 360 degrees. Okay, because that's the distance all the way around, divided by n, where n is the number of sides of the polygon. Okay, now the area of regular polygons, we use this formula, this following formula right here. To find the area of a polygon, we use the formula A, meaning area, is equal to 1/2 times the apothem, okay, times the perimeter. Okay, so we can use this formula to be able to find what the area of the polygon is going to be. Okay, this first example isn't too awfully difficult. We need to find the area of the regular polygon. And remember, this area formula only works for the regular polygons. And round our answer to the nearest tenth if we need to. So I'm just going to remind us here, the area is equal to 1/2 times the apothem times the perimeter. Okay, and all we have to do is just substitute information in, just like we've normally been doing, right? So our area is going to be 1/2 times the apothem, which is the distance from the center to the midpoint of the side, which is 12, times the perimeter. Okay, and the perimeter is the distance all the way around the polygon. We have one side is 11.6, and remember, if this is a regular polygon, that means every single one of these sides is going to be the exact same. Okay, and we see that there is 1, 2, 3, 4, 5, 6, 7 sides. So we're going to take 7 multiplied by 11.6, and we get 81.2. 81.2. Okay, now all we have to do is just multiply all of this information to figure out what the area is. 81.2 times 12 times 1/2, or 0.5. Press enter and we get 487.2. So our area is 487.2 units squared. Remember, if we aren't given a unit, a specific unit, we use the word units. All right. So that first example wasn't too difficult, but now it's going to get maybe a little bit harder here. Okay, so we again are trying to find the area of this polygon, and we're going to use area is equal to 1/2 times the apothem times the perimeter. Okay, and if we plug in the information we're given here, we can put in that the apothem is 6 times the square root of 3 but we do not know what the perimeter is. We still are not sure about what the perimeter is going to be. But here's the good news. We have enough information, even though it may not look like it, we have enough information to be able to figure that out. And the reason why we have enough information here is because we can use these pieces of information to figure out what this side length is, to figure out what the entire perimeter is. Okay, and that is using our trig functions, those glorious, wonderful trig functions that you guys love so very much. Okay, now here's what we do know: that this is the center of the polygon, and the entire distance around it, an entire distance of a circle is, or degrees as far as that goes, it's going to be 360 degrees, right? Now this is a regular polygon. Okay, that means that the amount of sides we can cut each one of those, finding the center angle of a polygon by taking 360 and dividing it by the number of sides there are. So 360 divided by 6 sides, since this is a hexagon, is going to give us 60 degrees. That means that each one of these triangles that we make is going to be 60 degrees. Now this apothem bisects this angle. That means this angle right in here is going to be half of 60, which is 30 degrees, and I know that might be a little bit hard to see, but this is going to be 30 degrees, and we already know that the distance of the apothem is 6 times the square root of 3, and we want to find what that little side length is. Then we can use our trig functions, right? Because the opposite over the adjacent means we're using our tangent function. Okay, so the tangent of 30 degrees is going to be equal to our opposite, x, divided by our adjacent, which is 6 times the square root of 3. And now all we have to do is, just like we were doing the last time we were doing this stuff, the trig stuff, multiply by 6 times the square root of 3 on both sides. Those will cancel out, and I'll be left with 6 times the square root of 3 times the tangent of 30 degrees is going to give us our x. Okay, and so we can just plug that into our calculator here. 6 times the square root is this button right down here, second to that button. 6 times the square root of 3, now make sure that you have to press over to get out of the square root when we're done with it, times the tangent of 30, we get 6. Okay, we get 6. That means x is equal to 6. Now that's this tiny, let me move it, tiny little distance right here. Okay, the entire side is going to be double that. That means each side is going to be 12 units in length. Okay, so now to figure out what the perimeter is, all I have to do is multiply 12 times 60, or sorry, 12 times 6, since there are 6 sides. 6 times 2 is 12. 6 times 1 is 6, plus the 1 is 7, and so our perimeter is 72. Okay, and now this is super easy. Now all we have to do is punch that into the calculator here. We're going to have our area is equal to 1/2, or 0.5, times 6, let me put this in parentheses, 6 times the square root of 3, and the parentheses, make sure it looks just like that, times, what was our last number here, 72, that's the perimeter, 72. And we get 374, round to the nearest tenth it says 374.1. So our area is 374.1 units squared. Now I told you this is going to be a little bit more work than what we're used to, but let's give you another example to take a look at it from a different type of perspective here. We're finding the area of this polygon, okay, and remember it's 1/2 times the apothem times the perimeter. Okay, now our area is what we're trying to figure out. We have 1/2. We do not know what the apothem is, so I'm going to leave that blank here, but we do know that the entire perimeter is 20. Okay, we know the entire perimeter is going to be 20. And if the entire perimeter is 20, there's 5 sides, we can conclude then that 20 divided by 5 is just 4. That means each side length has to be 4 units in length. Okay. Now, to figure out what that apothem is, remember the apothem is the distance from the very center. I'm going to make a dot there and say that's the center. We want to figure out what the distance is, put that as an x, from this side, the midpoint of the side length to the very center of the polygon is. Okay, and we can do this again using our trig. Okay, so let's build a little right triangle here. And we want to find out what this angle is, and we can do that by using that centroid angle. What was it called? It was the central angle of a regular polygon. Okay, by doing 360 divided by the amount of sides there are, which there's 5. 360 divided by 5. Okay, and we can use our calculator here. 360 divided by 5 just to make sure, and that's 72. Okay, 72 degrees. Now that's saying that each one of these angles, the full angle, is 72 degrees. We only want to know what half of that is. So if we divide that by 2, we get 36 degrees. Okay, so this angle right here is going to be 36 degrees. All right, now here's what we do know. We know that this, the apothem bisects the side length. That means that this distance has to be 2, because this distance is also going to be 2 as well, because the whole side length is 4. Okay, and now we have enough information to use that trig stuff, right? We know that the opposite over adjacent is going to give us, we can use that to figure out what the adjacent now the trig function that we use when we use opposite and adjacent is, of course, tangent. So the tangent of 36 is equal to our opposite, which is 2, divided by our adjacent, which is x. Okay, and now we can use that information to be able to figure out what x actually is, which is what we want to know. That's the length of the apothem. So we just multiply by x on both sides. We'll get x times the tangent of 36 is equal to 2. And then solving for x, we're just going to divide by the tangent of 36. And we get x is equal to 2 divided by the tangent of 36, which I don't really know what that is, but I can use my calculator to figure that out. 2 divided by the tangent of 36 is 2.8. We'll say it's 2.8. So go back up here, put 2.8. But remember, when we're using a calculator like this, it's good to use the entire value of that number. So we're going to multiply 2.8 times 20 times 0.5. So we're going to just say multiply right here using our answer from above. 20 times 0.5, and we get 27.5. So the area is 27.5. And we see that we're given a measurement here, a unit. It's meters squared. And that is the area of that wonderful pentagon.